Data center development is moving fast, and so is the computing technology that lives inside these buildings. The AI boom is accelerating just about everything, placing a premium on innovation. So, what does data center innovation look like in 2025 and beyond? To explore this question, we turn to Phill Lawson-Shanks, the Chief Innovation Officer at Aligned Data Centers. Phill has been involved in transformative work in the sector for years, from the edge of the network to the heart of the data hall. On today's show, Phill shares how modular designs are helping Aligned keep pace with new technology, adapting to changes in power and cooling infrastructure, and all the while staying keenly focused on sustainability. Let's get started. Welcome to Data Center Richness. I'm Rich Miller, and I've spent 25 years telling the story of data centers, cloud computing, and AI infrastructure. In this podcast, I'm sharing conversations with the innovators building our digital future. Now, here's our show. Phill Lawson-Shanks, welcome to Data Center Richness.
Thank you, Rich. Good to see you again.
I always enjoy talking about the data center industry with you. You've been a chief network officer or chief innovation officer, rather, at a time where there's a lot of innovation going on in the data center industry. We always like to start by talking about our guest's data center journey. So maybe kind of give I know you've been doing things in the industry for a while, so maybe give us a short backgrounder on your career and how you got to your current position with Aligned.
Sure. Like I say, we could take the whole session up with that. But yeah, I started before this was even an industry. My background, I found my way into programming mainframes for a little while. But being dyslexic, which I found out wasn't a good idea when you're programming in Fortran and COBOL that take 24 hours to compile. Not smart. But I saw the growth of the PC server technologies. I rode that wave through with Novell and LAN Manager and SCO Unix and Banyan Vines, all those things. Found my way into the computer industry as a result, and that brought me to the Americas. I worked for Compaq back in the day, did some wonderful things with them. Yeah, I found my way to a WorldCom, which was a fascinating time. At that point, they owned most of the internet assets around the globe. So I was monetizing that, did some interesting things there. And from there, I've been doing turnarounds and startups for the longest time, just in this industry. So I'm fortunate to work with some of the most brilliant people in our industry. Learned internet, learned data centers, early virtualization, early cloud. My previous role, where I think we first met at EdgeConneX, where we had to fix the internet because of content streaming was breaking it. Did some tremendous things there. That was amazing. And then I specifically came to Aligned because of the sustainability story. I was very aware that we were building buildings that we were monetizing over 25 years. The cooling technology was being depreciated within the cost of the building, which was fine if the technology was static. But obviously, even back then, it wasn't static. There was an 8-year technology refresh. So we had to think about different types of cooling. In those days, you could always get more power into a building. It's somewhat different now. But once the cooling was set, it was a set technology. And that brought me to looking at new ideas, new technologies. And Aligned had some incredible technologies from their Intertech days. And I took the jump, and it's been a tremendous ride here ever since.
Yeah, Aligned has grown very quickly, is building a lot of capacity in a lot of places. Uh, the, there's so much growth in the industry. We've all seen all of the headlines, the incredible funding, the size of the campuses that folks are building. Um, but there's also a sense of acceleration in terms of everybody trying to do what you do in building and delivering data centers. On the innovation front, how do you think about that as we enter a period where innovation isn't kind of an option for people with ambitions? It's really essential simply to adapt to the way that the industry seems to be moving.
That's very true. I think in all industries, ours, because that's what we're talking about, we always try and build on what's come before. So if you look at most data centers, up until maybe even 4 years ago, a lot of them were built like the old computer rooms were built because there was a knowledge base there. There was a supply chain. There was engineering understanding. So raised floor, cracks and all of that sort of stuff. At Aligned, we basically threw that rule book away and said, what do we need to do to be the most efficient and most effective platform for all of this technology that's coming? And if you look at a hyperscaler data center, which is really more like a warehouse, slab floor, the way they design their drop ceilings, if they have drop ceilings. So we modeled against that. And because of our cooling, we didn't need an underfloor plenum, which was ideal. So that sort of broke a lot of those rules and regulations. But the view of trying to anticipate what's coming, that's the challenge. And a few years ago, that was an easier challenge than it is today. Things are dramatically changing. We were used to an 8-year tech refresh cycle. That was the typical data center marketplace. A client would deploy their technology. Technology would continue to iterate, but they would wait until there's something significant before they did that lift and shift or replacement or a new build. We're seeing, the churn cycle now for the AI accelerators, whether they're a GPU or an ASIC or a whatever. That's 18 months down to they're moving towards a 12-month cycle. There's some challenges there with distribution of product and services, but if we follow that path, we have clients now who we're designing a product for today. They've contracted to take that space when it's built, which could be 12, 18 months' time. But during that build cycle where we're doing permitting, we've got supply chain, we're doing all the right things, they come back and say, we're taking the next chipset. So we need a different density profile, a different weight profile, different power distribution, different heat envelope. So it makes it a lot of fun. I often joke about this. We've optimized for cloud over the last several years, and we can do that. I still believe we have the most efficient deployment methodology for cloud services with our supply chain, our design, all of those wonderful things. But it was, we stamp it out. We buy the land, we provision the power, make sure that the network functionality is there, and we could do that all day long, and we have done. We've grown at a tremendous rate. Now it's a real engineering challenge because we're trying to anticipate an unknown because the client doesn't know necessarily what the hardware framework is going to be. Their supply chain of those key components, whether they're processors or memory or drives or even the fabric, the structure of the rack that it's going into. That's sort of being designed on the fly. We used to talk about we're flying the plane, building as we go. Well, now we're building it and we're trying to determine where we're going to land it, and we have to build that runway at the same time. So it's a fascinating challenge, but I think we have some of the smartest people in the industry that are focused on that and working with our partners and our supply chain to try and anticipate where we need to pivot or where we can really put a stake in the ground and move forwards.
You mentioned the hardware refresh cycle, and when you're working within the server or chassis, one of the concepts that we've seen for a long time is modularity and being able to swap components in and out and quickly be able to upgrade things, which is one thing when you're dealing with a rack or a server, but it's another thing when you're dealing with a data hall or a building. As we see very rapid advances in the roadmaps for the AI accelerators and the technologies to come. How is Aligned thinking about that? I know you've been thinking, about modularity for quite a while, but how does that apply in the current environment?
Oh, it's everything. It's absolutely everything. So the items that are I wouldn't say in flux, but the unknowns or the uncertainties. Obviously, it's based around the chip. As the chips become more powerful, they need more power, maybe a different type of power than we're used to delivering. They require a different form of heat removal. The density of the cabinets that are coming in is greater. I mean, we've designed for typically 4,000 pound racks, rolling weight off the dock, static weight. We're typically seeing 6,000 and now 8,000 pound racks wanted to be deployed. So that causes a different set of challenges when it comes to the engineering and civil work that we need to do. The size of the cabinets are different. We're looking at one of our clients that they're taking. It's essentially the space of three cabinet widths. It's one unit, but it's effectively three cabinets welded together. The compute's in the center. You're looking at heat distribution on one side and power on the other. That's pre-racked and stacked, coming off a truck, rolling into space. So just the rolling weight, the angles as it has to turn, and these are usually on autonomous dollies, autonomous moving devices. So just the standards that we have to do for that. So that's just moving the gear into space. And for that, we do a lot of work with OCP, the Open Compute Project, which came out of Facebook Meta years ago. That seems to be the structure that most people are moving to from a rack physicality. So working with them is critical. So that's just moving the technology into space. Then for removing the heat, right now, single phase liquid cooling to the chip is what everyone's doing. Clearly, you need a lot of air in that space as well because you're just removing 70–80% of the heat load from a server just by the liquid. So there's the DIMMs if they're not liquid cooled, there's the power supplies, there's all the other components, the storage, the network, all those things need air. So we have to provision, we over provision on both sides. And I think Mike, our CTO, in one of our previous interviews, he was talking about that 70–40, 80–30, 90–20. I mean, these things, we have to consider all the ability to do that. So with our cooling, we've designed that as a modular unit. The delta cube, we can bring those in or we can remove them if we need to. The delta flow, again, we can drop those in. It has the same footprint as the delta cube array. So we can add and subtract as that workload fluctuates from heat. The power is something else entirely. Now we're using AC power right now. It's low voltage power. That's going to change. That will change to a higher either current or amperage, potentially moving to DC power. But it won't just be the whole suite is DC. It'll be certain components will be DC power. So whether we do in-row rectifiers, or we have to think about the whole supply chain of power from utility all the way through our infrastructure to deliver that. So for that, all of our electrical rooms within the buildings are on skids as well. And we did that primarily for ease of use, ease of deployment, ease of construction, also mitigating waste at the work site as well, which is terribly important for us. Because with the best will in the world, you're going to get shavings of copper, aluminum, or aluminium, as I'd like to say, steel, which invariably you'll get pieces of that leaching into the water table, which we really don't want. So as much as we can is built off-site. So having that modularity gives us the flexibility down the road to maybe swap out some of those key components or the whole thing. The UPS and switchgear, they're in containers, again, modular. We can drop those in and out as we need to, and the generators are aligned with those. So we've designed it to be as modular as possible, maintaining our supply chain so that we can deliver and redirect components as we need to meet the delivery timelines. But also, as I say, these buildings have a 25, 26-year life in terms of financials, obviously much longer than that. So we need to monetize that appropriately and continue to create value for that physical fabric of the building that we're spending so much money on deploying.
I know Aligned has, an approach to that, the adaptive modular, that where you talk about use cases specifically where folks are transitioning between technologies and might have to swap out. This seems to be as we get, there's still a lot of cloud, there's all this AI, and we've got facilities that are optimizing for either one, but also some that are have to work with both. Uh, where are your clients on all of that? And uh, it sounds like that sort of hybrid approach can be enabled by the way you guys are thinking about things.
Exactly. Yeah. So for cloud's growing at a tremendous rate still, and will continue to grow. AI is the darling of the moment, and rightly so. So that's a huge market opportunity. But with AI, you still need cloud. They work. It's a symbiotic relationship. The technology in one relies on the data sets and processing of the other to deliver the functionality that we are all getting so used to every now and again. So we're seeing some of our clients who are saying this deployment is just going to be for large language models. I use that term very generically. There are lots of different ways they're doing that. But let's use that as an umbrella statement. So creating and refining the foundational models. And obviously that will continue. I think there's going to be continual iteration on those foundational models for the foreseeable future. Subsets will be taken off and a mixture of experts to make small language models. But essentially, that's a growth curve that's going to continue. So that requires a different thought process if you're going to extend and expand and invest in a fabric that supports that from a building perspective. Cloud, we know cloud. What we're seeing is a blend, though, of as a lot of those models, rather than hit those for an inference to actually get the question, more sophisticated enterprises are taking those models, small language models, and deploying GPU clusters or AI accelerators, because they're not always GPUs, within their existing cloud architecture to be the agent for their own services. Maybe it's a bank or an airline. They want to deliver an agentic utility model for their clients, or even just for business to business applications. But they want to keep that within their own cloud envelope because they want its data set to be their own data. And there's a reticence, I think, for some to keep a lot of that data in the public cloud. I mean, public clouds are very, very safe in their instances, but there's that fear that if something goes wrong, that maybe their data might get scraped by the larger AI model, and then obviously their intellectual property or whatever could go into the public domain. So and I'm not saying that's going to happen, but that's the mindset of a lot of our large enterprise clients. So they want to control their destiny in that regard. So we're seeing this hybridization of cloud services and AI technologies living in the same space, which ordinarily you'd have to design two entirely different rooms to do that, or buildings to do that. But because of our modularity, we can have them coexist very happily. High density compute, high density AI, liquid to chip, currently liquid to chip. If it goes two phase, we can do that too. If people want to do immersion, we could also do that. I haven't seen that in our client base just yet because realistically, the space it takes to have one or two of those tanks, you could put a couple of uprights doing direct cooling. Also, there's the refrigerant issue. A lot of that technology that's being used are still PFAS chemicals. So our clients are reluctant to do that. That's changing. There will be more and better products on the market in the next couple of years. So I think the next phase will be dual phase, where you have the liquid boiling off on the chip, much more efficient. You still get some radiant heat through the motherboard as well, even with that. So you still need air in that example, or some sort of cold plate between the servers. But that will take us to the next density. But also within that, the density is predicated by the proximity of the processors next to each other. We had InfiniBand. Now we're using the NVL backplanes or similar. AMD have a similar technology. So they want those for latency between the chips to be as close as possible. Things are changing in that space as well, which would enable some of this technology to be a bit further spaced apart, which will be ideal for legacy sites or people who are trying to blend that cloud architecture and some of these newer AI accelerations. But again, that's all future. I don't want to give up too much of what we're thinking about in our secret sauce. But those are the things we look at all day long. We spend time with NVIDIA, we spend time with AMD, we spend time with everybody. And the hyperscalers are making their own silicon. Understanding all of that and the supply chain. And this is a very holistic approach rather than just building a building, putting some power in, there you go.
One of the things that's been changing, obviously, time to market is the coin of the realm right now. Everybody's really, all of the companies focused on AI see the ability to train and train quickly as a competitive advantage. So everybody wants their data center space yesterday. At the same time, we're seeing power constraints in a lot of the key markets where folks traditionally have wanted to deploy. And so there's this whole other layer of understanding energy and what the options are, and if there are quicker ways to market. As the chief innovation officer, what sort of strategies or options, are there that you might be thinking about in terms of being able to work with utilities and some of the sort of grid level, reform and innovation that's going on there? Where does that fit into the picture?
Mm. So that's critical. Historically, we would buy land where we knew the internet was or was going to be, assuming we'd always get power. That's obviously not the case anymore. Back in the 50s, the Americas had the most sophisticated grid architecture. And with plentiful low-cost energy, that was one of the key drivers to the industrial growth that we've seen over the last several years. That there wasn't enough investment in keeping that technology up and regulated appropriately. So it's not so much the generation, it's the transmission, the long haul transmission. That's where the challenge is. It just takes too long to bring that to bear. So you can find pockets of power, and we specialize in doing that. One of the key things that we're looking at is old industrial sites that we can repurpose. We can clean up, which is very important. There was a coal power site we did. There was an industrial complex that we've done. Even this is a funny one. There was a rose farm in the Phoenix area that we took over, cleaned that up. In all those cases, there's infrastructure that we can bring to bear, local power that we can re-energize. But moreover, because of the cleaning aspect, we improve the environment, but also we use an awful lot less water than the previous industry. In some cases, 98% less water than the previous industry we're not displacing, but we're reallocating the space for. And also there's the economic benefits within the community. We spend a lot of time working with the community, with the schools, teaching them about this is an industry they could be part of, because we absolutely have a deficit in the trades in this country. Well, in fact, globally, we need to focus on that. So we do a lot of that with just the pockets of power we can find, and there's more. We're looking at some AI tools that have been very helpful to some of the large utilities, because when they provision power, they need to accommodate for that worst moment where the power needs to be created. And sometimes you can reposition that, and we've done that successfully in the Pacific Northwest. And we're looking at that for other sites as well, to work with the utility to help them refine their distribution methodologies. But also, I mean, the nirvana will be self-generation, or not say self-generation, but local generation of nuclear power, SMRs, advanced SMRs, particularly the walk-away safe technologies. Those will be, I believe, those will be in marketplaces to serve the data centers within that space and also the local community. Because we'll all do a PPA, we can enable them to over-provision their energy resources so they can deliver to the communities. And we'll take the power through the local transmission resources rather than private tethers. I think that's where it's going to be. And then over time, the transmission will catch up in terms of delivering that overuse or that over generation to other regions. But I think for the short term, it's a case of finding power where it is, using alternative power technologies like gas recip engines. And then obviously the goal is to move to small modular reactors. And that's just not the data center business. I think that's industry. We've moved to an electrification of the country. And this is an absolute requirement to make that happen.
Yeah, it's really interesting that with the energy issues and the challenges that we're dealing with trying to manage, one of the areas that's kind of in focus, and I've been thinking a lot about, is sustainability and the energy mix. There's a lot more discussion of natural gas as an important bridge between where we are now and getting to nuclear. At the same time, there's growing generation of renewables, but being able to get it on the grid and where it needs to be for to help data centers isn't always easy. Um, what's your take on where we're at on data center sustainability, which has been front of mind for a long time for the largest clients, and where we're headed from here?
Well, that's part of our core DNA. That everything we do is based on sustainability, where we build, how we operate, our supply chain, all of those things. One of the things we're very focused on the Green Build Initiative right now, the GBI, the Green Globes, and I like those because they come in at the design phase. They start looking at how we're designing the building and follow that all the way through. They check up on our waste avoidance that we do all the time with our construction, and then come back and reassess again. So we have, I think the most we have is three. We're aiming for four. It's just a little bit we've got to do to get to that fourth Green Globe. But that's fundamental to how we see the world, but also how we work in the community with we build and donate orchards, fruit orchards. The teams go out and actually dig the holes and plant the trees for local food banks. So many things. The materials that we're using for the buildings. We've used steel sandwich plates for walls in a couple of locations, which again, obviously no concrete, which is great, no Portland. We're very committed to the whole embodied carbon traceability. We actually we kicked that off about 5 years ago now. We're fundamental in helping build the iMason's Climate Accord. So we had to encourage the hyperscalers with the biggest spend profiles to actually be part of that process, and it's happened. We're having all of our suppliers go through that to give us their greenhouse gas emissions, their ESG. Basically, they would define their life cycle assessment documentation or their environmental product declaration. So we can do a roll up of all that data from not only the electrical equipment, the cooling equipment, mechanical, the fabric of the building, and we can give our clients as accurate as possible. This is a journey, not a definitive. This is the number. It's a journey, but we can give them that data to report on their scope 3 for their ESG reporting. So sustainability will continue to be at the forefront of everything we do.
There was some really interesting discussions a couple of weeks ago. I saw you in one of the some of the panels at the Yada conference. There were some great conversations about cooling and all that's going on there, and including how many pipes we're going to need in the future. I just wanted to follow up a little bit on the sort of future proofing components of that. I had a good talk with Michael Welch about Delta Flow, the CDU and unit that Aligned has introduced to sort of be the successor to the air cooling. The company has always, its DNA really has been in cooling for so long. How are you feeling given the roadmaps that are out there? I mean, every time Jensen Wang makes an appearance, we seem to see higher densities suddenly in the pipeline. As a company with that legacy in cooling, where are we headed on that?
When I joined, we were doing 50 kilowatts of air and mixed densities in there and whatever, which was also the clients loved that because they could use less racks. They could have more gear in a single rack. So great sustainability story, less overhead cabling, less end of row switches, all of that good stuff. So 50 was phenomenal. With the DGX, with the Hopper, the H100s, when they came out, that was fine. We could do that all day long. When Blackwell came out, that was a slightly different beast, and particularly when they moved to the MGX rack, the which essentially there was the NVL 72. That's where things jumped up to 120, 130. So we had to go to liquid. Looking at that roadmap, if you follow it through, we're looking at 600 kilowatts, 1.1 megawatts, 2.2 megawatts per rack. Now, to be clear, it's not just a single rack. That's like a three components together. But even so, you're looking at in what typically a space where you'd have 10 megawatts, you could potentially have 40, 50, 60 megawatts in that same footprint. Now, that's not necessarily feasible because of the power distribution. There's a whole other set of things there, but we're seeing this rise in power usage and heat density, which is why we developed the Delta Flow. Because when we started developing it, there were some good CDUs on the market, but we wanted to ensure that it sat within our engineering framework, so that we knew that we would have to add components and remove components. It had to be a balanced architecture, particularly because once you're removing the heat, whether it's through a heat exchanger or through our CDU's our Delta Flows heat exchangers, we're using the same liquid loop. So we need to maintain that because everything goes back to that, the exhaust of the heat into the atmosphere. So understanding that as a holistic model, again, is vitally important. So I feel very confident that whatever comes down, whatever Jensen says next, and whatever our clients want to do, we can add the components to do that. And we like to think of it as we add them in series. So it's very much like an N plus one, like with a UPS, a generator lineup. We're adding redundancy in by adding components, which enables us to be very efficient with the technology. We see it, everything's modular. We have to look at this as a modular structure and follow that power and heat curve as it grows, because it is so unpredictable at this moment in time. It's so unpredictable.
Yeah, I wanted to ask about that sort of whenever we sort of wrap up a conversation. I always like to ask about the road ahead, because when you look at the rate of change, just over the past, if you want to look at an inflection point, let's talk about since ChatGPT came out in November of 2022. We're not even 3 years in, and the world is changing, particularly when we see some of these projections of how much compute some of the players in this space believe that they'll need, the data center capacity to go along with that. As someone who's been working on the front lines of innovation for a long time, what do you think if we think about the next 5 years, what's your framework for trying to get your head around it?
Sure. I think you have to think of it as a bifurcated market now, at least bifurcated, maybe trifurcated. Certainly with the large language models, there's going to be a lot of refining of those. I think what's going to happen is you're going to see a customer, they have a particular set of technology working on that model. They'll want to double the chip count or triple the chip count, because every request you make, every set of inference you make to that, obviously it's working through, you get the tokens, it comes back and gives you the answer. Sometimes there's still some hallucinations in those. There's a lot of work to refine those models. But if you can have as many paths as you can working on that same problem and then compare the results and then determine what is the most reasonable to deliver the answer. And obviously that has to be done, it's very time sensitive. So the only way to do that is to scale out of technology to do that. So I think the large language models are going to get larger. The people who are supporting those, their infrastructure is going to get larger and larger. It's building scale now, it's going to get to campus scale very, very quickly. And again, that's based on some of the technologies for networking the components, but we don't need to go into all of that. So that's just going to grow. I think we may see some consolidation in that marketplace. I think there's going to be probably the Magnificent Seven will own that from a large language model perspective. From the neo clouds, they're growing tremendously, so they're benefiting from the relationship they have with the processor companies, and that's wonderful because not only are the hyperscalers using them as well because it's just a faster way to get more processing, but also for enterprises to start using that technology to actually start working on the models and creating their own agentic framework so they can actually bring those down into their enterprises. So they're going to grow some more as well. Cloud is obviously growing. We've talked about that. But I think I think this is a resurgence of the edge. And you and I, we talked about edge for a long time. It's the lowest latency point between the service and the consumption of a service. I think we're going to see a hybrid cloud AI edge that's going to look differently. Obviously, the existing edge data centers can accommodate that if they can accommodate the heat and cooling, the heat and power profiles. But I think we'll see a new breed of those coming out, and they might look entirely different. Some of these agentic far edge processing units. That's not a place in which we play. But there's a huge market opportunity, I think, to start thinking about getting compute, whether it's cloud, whether it's content distribution, whether it's AI, agentic learning, or whatever, having those as far and as close to the endpoint, whatever that happens to be, a phone, a headset. I mean, all of that's changing as well. Once we start looking at, Apple, I was one of the, I'm a, a fanboy for Apple. I bought one of the Vision Pros early on, and I'm still trying to find a good use case for it, but I'll keep doing it. But you're seeing what Meta are doing and others, and maybe the future Apple heads-up displays. That's going to change things again. So you have tremendous compute capacity in your pocket. It's all going to be tethered to a phone of some sort. But again, having that high-speed connectivity to a local agent or agentic tool set to deliver and work collaboratively in a client-server architecture to deliver those functions, because lossless communication is vital, particularly when it's the eye. Our perception of frequency change. I mean, it's funny, I still challenge anyone to see the difference between a 4K and an 8K television, because the receptors of the eye can't actually see that. But it's great. It's a great selling point. I have one, but I can't tell the difference necessarily. But when you get to that level of you're looking at something, you'll say, what is that? What is the context of that thing or person, place, or thing, and having that immediate response so that it could be part of a conversational flow. For that, we need much more compute at a much closer point to the end user case. So this is just great. It's a fantastic time to be alive, I think. So lots more big data centers, lots more smaller data centers, lots more compute everywhere.
Well, it is indeed a exciting time to be in the industry, and I always enjoy the way that you can describe this amazing path that we're on. And now you've extended your innovation to using stairwells as podcast studios. So I very much appreciate the effort you made to be able to spend some time with me this morning. So Phil, thanks so much.
You're welcome. It's been a pleasure. Love your show. Love watching it all the time. Thank you.
Many thanks for listening. If you like our content, you'll want to check out the Data Center Richness Substack, where I'm sharing lots of additional insights on the fast-moving data center and AI landscape. If you're a data center professional, you'll definitely want to check it out. If you enjoyed today's discussion, please give it a like and be sure to subscribe to our channel, as it supports my work and ensures that you won't miss out on any of our insights from data center richness.